It's a true pleasure and honor to be with you all. It's good to be breathing the air of Texas again. I miss it. So my three kids were born here, so anyway, maybe we'll get down here again sometime. I have a title here, The Scientific Case for Intelligent Design. What I really want to focus on is, why is this science? I mean, it's one thing to say that we've got various scientific arguments and we're looking at certain scientific features of the world, but really to try to trace a little bit more the logic of this. You know, how did we get here? Why is this really a scientific program and perhaps not just a religious program that's using science or abusing science, as our critics might charge? So that's what I want to do. I'm going to cover or intersect a little bit with what Steve was saying. In fact, we talked a few days ago about just how could we merge our talk since he was going before me. So I have a standard sort of talk that I give. I'm going to, some of this will look familiar, but then we will get into some new territory as well. So let's just get back the definition of intelligent design. The one that I use, and it's very similar to what Steve gave, the study of patterns in nature that are best explained as the product of intelligence. Steve used the phrase key features, but I like that notion of patterns because that's really what we're looking at. We're looking at patterns, certain things that really then will key off of, will show us that we're talking about designed things. Now, if we define intelligent design that way, we find all sorts of patterns in nature. But if you look, for instance, this is the cloud formation. Is there anything in this cloud formation which would suggest to us that we're dealing with an intelligence? Probably not. I mean, you know, if you've got a good imagination, maybe you can see Santa Claus's beard or something like that. But it would not really be compelling. But what about if you saw something like this? That's also a cloud formation. You know, what about this? You know, I think at some point the patterns can get so stark, if you will, that it leaves us no doubt that we're dealing with an intelligence. You know, we might say that this is, you know, maybe there is some pattern there that we're just missing it, okay? But something like this, there's no doubt. And now, if I define intelligent design that way, is it the same thing as creationism? A lot of people want to say it is the same thing because then they can discredit it, because creation is always ultimately a theological or religious doctrine. Now, why is that? And that's nothing against creation, okay? But it's just intelligent design is something that's different, and I want to just make that clear because our critics will often try to say, well, it's just the same thing. And there is a real distinction. And you can see the distinction really by looking at the opening chapter of Genesis. What does God do in Genesis? He brings the world into being. Okay, it's a creation out of nothing. In the beginning, God created. He brings a world into being, and then what does God do? God orders the world. Okay, He separates waters, creates life, puts stars up. So there's an ordering process, and what design talks about is the ordering process, getting the order into things so that it accomplishes, in this case, God's purposes. So there's the raw materials, if you will. Where did it come from all? And then how is it put together? There's a joke that was making the rounds some years back. It runs as this. Scientists come to God and say, you know, you're out of a job. We can do everything that you can do. And God says, oh, that's very interesting. What do you have in mind? And they say, well, we can create humans from scratch. And says God says, okay, show me. And they said, well, first we take some dust and then God stops them and says, well, get your own dust. Okay. Now, the problem is, you know, where do you get the stuff that then gets organized to be designed? Okay, that's the challenge. And creation is about where does that primordial stuff come from in the first place? Design asks, how does it get organized? And so it's a difference. Okay, you may say, well, they're related. But the thing is, in our case, when we're dealing with design, we are designers, but we're not creators in that sense that we are the originators of the original stuff. So one way you could illustrate it is if you think of this as God as the creator, this image, then you can contrast that with a carpenter who takes pre-existing materials and then arranges them. And it's interesting to me, just throw this in, that Jesus' first job, it seems, was that of a carpenter. And it's interesting, theologically, there's some interesting resonances here because Jesus is the Word of God who is the instrument of creation. And this is how the Scripture is presented. But that's just by the way. But anyway, so intelligent design, the study of patterns in nature that are best explained as the product of intelligence. Now, if we say patterns, that's really another word for information. In fact, the word form, and we use that when we talk about Platonic forms, patterns, the pattern in heaven that is then exemplified here on earth. Now, information actually is something that is well understood. There's a well-defined theory of information. I'm going to talk more about that tomorrow, but I'll just touch on it here. But we can think of intelligent design then as a theory of information. I'll say something more about that. But as a theory of information then, it is fully a part of science. Now again, I'm going to have to expand on that, but I just want to say that it's not just that we have this intuition, gee, these things sure look design. I explain it best as a product of design. You guys haven't explained how it could have formed by purely natural processes, therefore we have a science. It's not just that design is the best explanation, now we go home. It's that there's more work to be done. Okay, this is what I want to explore. Because if at the end of the day intelligent design just says, well, it's designed, that doesn't really allow scientists to do a whole lot. So this is where I'm going with this. Okay, now, there is a huge challenge to intelligent design that it isn't science. So one way I like to soften up, especially hostile audiences, is to say, okay, well, there are lots of special sciences that already are really doing intelligent design. If you think of this general definition, the study of patterns in nature best explained as the product of intelligence, well, there are a lot of special sciences that fall under that are recognized as sciences, where there is no real controversy. Forensic science. Is that body on the carpet dead on account of natural causes or on account of foul play? Foul play would be design. Natural causes would be result of, well, natural causes. So we've got television programs that are devoted to drawing that distinction. And it's really a basic part of human rationality to try to distinguish between things that are the result of intelligent causes and things that are the result of causes, for all we know, that may not be intelligent. And our very language distinguishes these. We have the words random, accidental, noise, and then we've got words like designed, purposeful, structured. So we've got all, our very language distinguishes between these two modes of explanation. SETI, Search for Extraterrestrial Intelligence, that was adverted to by Steve. I'll skip through that. Archaeology, is that an arrowhead or is that just a random chunk of rock? Is this a burial mound or is this just a naturally formed mound? We ask these questions in all sorts of contexts. Stonehenge, did these rocks just arrange themselves or was there some intelligence behind it? This is a little guilty pleasure of mine, a movie, This is Spinal Tap. If you know about it, about the Stonehenge example, you'll recognize that this is a subtle literary allusion here. Mount Rushmore, This formation of rocks if you drive through southwest South Dakota, how did this form? Does wind and erosion bring about structures like this? Well, that's not a good enough explanation. That's like wind and erosion are causes now in operation, as Steve Meyer puts it, citing Lyell, but it's not the sort of cause that brings this about. By the way, this is not widely known fact that this is the opposite side of Mount Rushmore. Just thought I'd share that with you. Anyway, this is at the real Mount Rushmore, and it's not quite what I just showed you. But anyway, but that's it. But you can see, this is very complicated rock formation. This formation will not be anywhere else in the world, and yet this is the one which we know to be designed. It matches up with a pattern of precedence that we know. We'll talk more about what is it that actually triggers this design inference for us. Cosmology. Steve Meyer talked about this, fine-tuning. of these cosmological constants. And then biology. Okay? Now, if I put it this way, this seems then perfectly reasonable transition, right? I mean, we look at all these other special sciences in which this distinction between intelligence and natural forces, we draw it reliably, it's important. In fact, the science would not exist without being able to draw that distinction. And note also, I mean, just to go back to, what do we have? The search for extraterrestrial intelligence, that goes back a little bit further. But it's not with the search for extraterrestrial intelligence that we actually see the little green man, right? What we're doing is we're getting radio signals from outer space, and then we're saying, no, this isn't noise, this has some sort of structure. Now, that would be ideal if the real-life SETI program could find that. There has been no signal from outer space that has convincingly exemplified an intelligent cause. But that's what people are looking for, and they're thinking that from just that radio signal, they can see a structure in it which would allow them to infer an intelligent agent. Anyway, so biology, it seems we're doing the same thing. Here, there's an animation that's connected with it, but Steve, I think, even showed you a better animation, so I'm not going to do that. But just this is a YouTube video, Inner Life of the Cell, and just this alone is enough, I think, to illustrate, just the complexities and the nanotechnology inside the cell. You could think of this as a little kinesin motor. You should think of this as a UPS truck, delivery truck, and this is the back of it, which has a little parcel in it. And there are all sorts of little tags on there which are telling it where to deliver the parcel. And this is you can think of this as a monorail along which this UPS truck is delivering a parcel. And this is, transportation and distribution systems. Those are inside cells. And all this fancy technology that's inside cells. So, it's not a stretch to think, well, maybe there is real design inside the cell. But when you pose that question, all hell breaks loose in the scientific community. Why are they so resistant to this? And when I say all hell breaks loose, I'm not exaggerating. But the problem is, in all these other cases of design detection, SETI, search for extraterrestrial intelligence, archaeology, and whatever, the intelligences that would be involved would be evolved intelligences. SETI, search for extraterrestrial intelligence, the scientific community thinks that the little green man who is sending you that signal from outer space also evolved by some Darwinian process just as you did. Problem, though, is if we are finding design inside the cell, who or what is the design or the intelligence behind it? Okay? Well, it would have to be an unevolved intelligence. Now, you might say, well, maybe it's an alien intelligence that designed and seeded life on Earth. But if that's the case, then where did they come from? Eventually, you get pushed to an intelligence that's not the result of evolution. Now, when that happens, when you have an intelligence that's not the result of evolution, what sort of intelligence would that be? Well, very quickly, you no longer have materialism and atheism as an option, right? It's an evolutionist needs, an atheist needs an evolutionary account of things. There's no way around it. Everybody needs an origin story. The atheist does as well. I debated Christopher Hitchens 3 years ago at Prestonwood Church in Plano. This is shortly before his death. He's got a book, God is Not Great. And chapter 5, I think it was, he has a whole chapter on Darwin and design, refuting design and touting Darwin, and giving examples of the inverted retina and things like that. Now, why is Christopher Hitchens, a lit guy, having a whole chapter in a book on Darwin and design? Did you catch that? A lit guy. This was his thing. He's not a scientist. Why does he need a chapter like that there? Well, he needs it because that's what buttresses his atheism. The atheists don't come to us and say, I'm an atheist because I just want to believe in atheism. It's just, you're Christian, you're a fideist, you believe in Christianity because that's just, your believism. And I've got my believism, I'm an atheist. That's not what they come. They're coming to you as these supreme rationalists who have looked at the bleakness of reality in the face and have come to terms with it and now have made their peace and know the truth. And we are the benighted ones who don't see it. That's how they view it. They are the Promethean ones. They're the courageous ones. That's how they come to us. And so for an intelligent design guy like me or Steve Meyer to say, hey, this is bunk, Your origin story doesn't hold up. The evidence is for real intelligence right at the origin of biology. Suddenly, that you've got a designer that's not tied to the material world. Getting very close to God. You're not quite at God, but you're getting very close to God. And that's too much to handle. And so, better just to discredit this view as quickly as you can. Anyway, I'm going to skip this video. And so the thing is, there's all this evidence then in biology, and I'll need to skip some of it in the interest of time also. But we see that this is a quote that Steve came up with, but we see this sort of quote over and over again. Okay, so certainly prima facie, at first glance, it would seem that biology is giving us strong indications of design, and that there are reasons to think design and argue for design as we would in other special sciences. And yet the biological community resists this, and they'll do this move that, Steve quoted this. This is page 1 of Richard Dawkins' The Blind Watchmaker. Biology is the study of complicated things that give the appearance of having been designed for a purpose. But he's not the only one who says this. I mean, this is a widespread sentiment in the biological community. Francis Crick, biologists must constantly keep in mind that what they see was not designed, but rather evolved. I'm a scientist in the lab. I'm looking at it, man, that sure looks designed. That sure looks designed. It's evolved, it's evolved, it's evolved. I mean, what a way to live. But this is the mentality. Richard Dawkins, I mean, he has been one of my greatest inspirations, actually. I mean, I should dedicate a book to him at some point, because he is wrong, but he's so insightfully wrong. I think this is what I find so useful about him. But he'll write in River Out of Eden, about 10 years after Blind Watchmaker, the illusion of purpose is so powerful that biologists themselves use the assumption of good design as a working tool. So we imagine ourselves as good designers, and then that helps us in our biology. Now, if it looks like a duck, quacks like a duck, does all these things like a duck, maybe it really is a duck. Anyway, Steve went through some of these things, but what are the things that we're looking at that are convincing us that we're dealing with design systems? And it's that especially, I think what has been key here has been the revolution in molecular biology in the last 40 to 50 years, where we're finding all sorts of nano-engineered nanotechnologies inside the cell, and at a level of sophistication that beggars anything that humans have come up with. So we've got information storage, retrieval, and processing, the genetic code, which Steve has so masterfully spoken about. Basically, inside every one of your cells is about 6 feet of DNA. It's inside the nucleus. If you stretch it out, okay, but it's fit into a very, very tiny little nucleus. The nucleus is maybe about 1/10 of a hair diameter in diameter. And that 6 feet has to be put in there. And it has to be not just put in there, but put in there in a way that it doesn't get tangled. So you've got to coil it, supercoil it, you've got all sorts of proteins to put it in there. If you imagine that DNA as a fishing line, I'm sure we've got some fishermen here, this is Texas. That fishing line, it would be, let's say it's a very thin fishing line, it would stretch about 600 to 1,000 miles, and every millimeter of that fishing line, you basically put a byte of information on it, something like that. It's 3 nucleotides, so 64, actually 64, it's a little bit less. So think of it, every millimeter is going to have about a byte of information. Now, all that fishing line, you could put it on this stage, okay? But it's got to be organized in a way that you can get to it, and the cell knows how to get to it, okay? It's a level of storage, an efficiency and reliability of storage that goes well beyond your thumb drive, okay? And that level of storage and that sophistication has been there. If we go with standard dating in biology, it's been there for 3.9 billion years. It's been there right from the start. Granted, those would be bacterial cells that would be less complicated, there'd be less DNA, but the technology would still be the same, and that is remarkable. Okay, I'm going to skip through a few slides again because I think Steve has done such a wonderful job. But this is the point I want to make. If we go back to even the most primitive cell, I think we have the sense of, our technologies evolve. You look at a car from the 1950s and 60s, and then we look at our, Toyota or Honda, or now the South Korean vehicles, the sophistication, the reliability, and all of that. We see just a huge increase in sophistication. And what we see instead in life is that we don't, as evolution happens, we don't have an increase in the sophistication. What we have is really something like the difference between a state-of-the-art smartphone and a state-of-the-art laptop. The bacterial cells, for what they do, they're doing things every bit as good and as precise and as efficient as our much more complicated cells which have nuclei in them. Okay, so it's a level of technology that is consistent across the board. It's not that we're seeing the technology getting better over time. It's the same high level of technology. It's just instanced in various different systems, where the systems themselves, because of what they are called to do, will have to be more complex or less complex. Okay, so I would say minimally, especially with the sort of DNA argument that Steve has made, and we can actually, the argument is even strong. I mean, much stronger than he made it out. I mean, he just touched on it. And I would thoroughly encourage you to read his book Signature in the Cell. But I think it's fair to conclude, and the thing is, Darwinian, or at least biologists who are not intelligent design people, who are honest about what is happening and the challenges in explaining some of these biological systems, have admitted this. Franklin Harold, in his book The Way of the Cell, this was an Oxford University Press book in 2001, wrote back then, there are presently no detailed Darwinian accounts of the evolution of any biochemical or cellular system, only a variety of wishful speculations. I raised this in a debate in 2002 with Ken Miller, and his only response was, Franklin Harold's an old guy, he's been retired for 15 years. Okay? This is, I think, very damning. This is the greatest theory that's ever been thought, Darwin. The greatest idea. If you listen to Daniel Dennett, Darwin, he puts to shame Newton and Einstein. Is the way he puts it. And the thing is, the same thing, virtually the same. 5 years earlier, James Shapiro, and it's the same language. There are no detailed Darwinian accounts for the evolution of any fundamental biochemical or cellular system, only a variety of wishful speculations. It's, what's remarkable is, this is really plagiarism, and this Franklin Harold did not even cite Shapiro, which leads me to believe that when scientists meditate on this problem and see what's really going on, they'll even use the same language to describe it, wishful speculations and all. But it's David Griffin. By the way, these are old quotes, but nothing has gotten better for the evolutionists, the Darwinian evolutionists since then. There's been an ENCODE project where you're looking at the DNA inside the cell, and what you're finding is, in so much of the research now, that things that were called junk DNA. In fact, the very notion of junk DNA is now being considered a scientific blunder. These non-coding regions of DNA do serve a purpose. So it's, if anything, these quotes, I should probably update them. But David Griffin, writing on Behe's work in 2000, says there are, I'm assured, evolutionists who have described how the transitions, how these evolutionary changes could have occurred. When I ask the books in which I can find these discussions, however, I either get no answer or else some titles that, upon examination, do not, in fact, contain the promised accounts. Such accounts exist. That they exist seems to be something that is widely known, but I have yet to encounter someone who knows where they exist. This is the argument from non-existent reference or irrelevant reference. You cite, it's been done in the scientific literature. Look in this paper, and then you look, and in fact, it's not what you asked for. And I could go on with this. I've got others, but it's, these Darwinian evolutionary explanations have failed. They do not account for these systems. If they did, we wouldn't be talking to you today. We'd be laughed off the stage. We have identified some real significant challenges to evolutionary theory. So there's this failed challenge to evolution. biological evolution to intelligent design. So you see, the great promise of the great promise of evolutionary theory was that it was supposed to have explained these systems, how you could get the appearance of design without a designer. And so we might put it in these terms. If an unguided evolutionary mechanism adequately explained biological complexity and diversity, then intelligent design is unnecessary. Unguided evolutionary mechanisms have adequately explained it. Therefore, intelligent design is unnecessary. Intelligent design was the go-to explanation before Darwin. Okay, but now we find that this doesn't work. Okay? Now, if it doesn't work, what does work? And how can we then have confidence in intelligent design? And this is where things get dicey. Intelligent design is proscribed or denied to scientific status as, it seems, a general principle by attributing the diversity of life to natural causes rather than supernatural creation. Note how they put it. You know, I've been talking about design, just how the design gets in there, whether it's supernaturally, naturally, or otherwise. That's I didn't address that, but it's this opposition, natural causes to supernatural creation. Darwin gave biology a sound scientific basis. Okay, by attributing the diversity of life to natural causes rather than supernatural creation, Darwin gave biology a sound scientific basis. The implication is that before Darwin, there was no sound scientific basis for it. Again, but in the interest of time, I'm going to skip. There's another quote I have which says the same thing. But the question then is, the received wisdom is that intelligent design can't be science. Okay? So how might we see that it could be? Okay? Well, I think one way to see it, and I'm just going to talk through this. Again, this is my talk could go longer. Who's this guy? This is Francis Crick. Was he a design theorist? Actually, he did biology, coming to it from physics because he thought biology was where the interesting problems were, and biology was where he could get the most traction against theism. I mean, he was an ardent atheist. But turns out he proposed a theory of directed panspermia. Panspermia is the idea that through the heavens, through the space, outer space, biological particles of some form are just floating, and then they come to Earth and seed it, and that's how you get the origin of life. Directed panspermia is that spaceships come and seed life on Earth. Now, he seriously proposed this, wrote it up with Leslie Orgel and Icarus, I think, and is that a purely naturalistic hypothesis? Well, if we were seeded here by intelligent beings, then we are here as a result of intelligent design. You know? So there's that. I'm going to skip that. That's a great little video with Richard Dawkins. But anyway, Steve Meyer, I plug his book. I do this at virtually all my talks, Steve, so I'm there. I'm in your corner. But Craig Venter, this is somebody who did the Human Genome Project, but privately, and he's got a synthetic genomics project in which he has taken DNA watermarks and put them in the DNA. He's put in Venter Institute, Craig Venter, Ham Smith, etc., as a way of claiming his intellectual property. Now, if you can write in DNA and design DNA, you know, what's to prevent DNA from being designed in the first place? So again, to say that this is not or cannot be a scientific program, I think really becomes problematic. There seems to be a lot of special pleading involved. We're designing our own DNA at this point, so why couldn't it have been designed in the first place? But I think the place where we may get even bigger traction is by looking at the very logic by which we identify or detect design. And I'll speak briefly about this. This is where my own research came in. This goes back actually about 20 years, but there's a whole method of design detection that I came on really as a mathematician, trying to understand the statistics involved with very small probability events. I was intrigued by these small probability events, and what I found was that these small probability events were used often not just to eliminate chance or to knock down a given chance hypothesis, but also to identify an intelligence. So let's look at that briefly. Go back to the search for extraterrestrial intelligence example. Here we've got Jodie Foster in the movie based on a novel by Carl Sagan. So it's, we're looking at, she's looking for signs of intelligence from outer space. And what persuaded the scientists there in the movie Contact that they had actually found signs of extraterrestrial intelligence? Well, if you saw the movie, there's a key moment where they get a long sequence of bits, ones and zeros. They actually come in amplified as pauses and beats. And so you get, what is it, 1, 1, 0, 1, 1, 1, 0, etc. And let's see, do you see it? The numbers are there, 2, 3, 5, 7, 11, 13, and so on. It's a sequence of prime numbers, and it's a long sequence of prime numbers. And when those radio astronomers get that sequence, they know that they're in the presence of an intelligence. So what is it about this signal that convinced them that they were dealing with an intelligence? Well, it seems that there are really two things that did it for them. They had a complex sequence. So it wasn't just 2 beats, pause, end of story. These extraterrestrials, they're real smart. They sent us the first prime number, the number 2. Okay. Well, if that's all you got, pause. What would that? If you're monitoring millions of radio signals, you are going to see 2 heads and a tails, 2 ones and a 0. But it's the long sequence. It's something that's improbable, that's complex, that's hard to reproduce probabilistically. That's one thing which you need. But it's not just sheer improbability. I could get out a coin and start tossing it. If I toss it long enough, I'm going to have a highly improbable event, a unique event in the history of coin tossing. But there'll be no pattern there that's going to convince you that there's any sort of intelligence behind it. So in addition, you need a salient pattern, a specification, as I call it. And so let me say a little bit about both these. So first, the connection between complexity and probability. Think of this combination lock. If you're turning the dials on this lock, the more possibilities there are, the more directions you have to turn it, the more complicated the mechanism, and correspondingly, the more improbable it is that you're going to open it by chance. Because that's improbability and complexity work together in this way. So why probability? Well, unless we discipline our use of probabilities, we can really explain anything. Okay, so science is fundamentally concerned with probabilities. We're dealing with empirical realities, things that have a probability of happening. And so the sorts of events that we want to rule out from happening by chance are those that are going to have small probability. Small probability isn't enough. It's not a sufficient condition, but it is going to be a necessary condition. So I'll give you 2 examples of why this is important. One, this is from the movie Spinal Tap. These musicians are sitting around and discussing how a long string of drummers in their band died in mysterious circumstances. And one of the drummers died by spontaneously combusting. Now, the fact is, I could this moment spontaneously combust in front of you if all the fast-moving air molecules suddenly converged on me. There is a probability of that event, It's not something I have anxiety attacks about. I don't worry about it. But it is because temperature is mean kinetic energy of these gas molecules, and if all the fast ones suddenly converged on me, I would be in trouble. But it's a very low probability event. Now, if that didn't drive the point home, I hope this following example will. This will be my one video here, so let's try to get the sound right if we may. Now, I would put it to you that our friend Jim Carrey is essentially our friend Charles Darwin, but in a different getup. And I realize that may seem harsh, but I think that really is what we're dealing with. What's within the reach of chance, what's outside the reach of chance, and how do we assess that? And it seems to me that this is in fact what's happening, that the evolutionary community, especially when they're trying to understand the origin of life, they are going to give chance a pass. They're going to say, it's not a problem. They're going to be that excited about it. So getting lucky, let us say, is not a good scientific explanation. But in addition to that, and I'll skip that, we also need a pattern. As I said, if you flip a coin 1,000 times, you'll witness a highly improbable event. But it's not just the sheer improbability, there's also a complexity there, or a pattern rather there that you've got to account for. So it's not just enough to have chance. But what sort of pattern will do it? Have a look at this. This could be, and don't blurt out if you see what the pattern is, this could be an ink blot, lots of ways to apply ink to paper. So this could be a highly improbable way of applying ink to paper, one of many, many possibilities. So it could be highly improbable, but if you don't see the pattern there, you might just say, well, it's just purely random. But if you do see the pattern there, you'll know that this was designed, right? How many see the pattern there? Okay, it's a little lower than usual because I think it's got a little bleached out here in this light. What if I tell you that you're looking at an animal? Okay, now it's probably a little clearer. How many see it now? Yeah. Okay, but I'd say we're still probably only about 15-20%. When I'm in Iowa farm country, it actually is quite a bit more. This is the cow, these are the eyes, these are the ears, this is the head, okay, this is the nose, okay. So now you see it, and notice, if you didn't see it at first, okay, it went from being random to being non-random, to being designed. And you will never unsee this again. I can push this off, put it on, ta-da, it's still there. So once you see it, the pattern was objectively there. You, with your background knowledge, though, needed to figure out, okay, it had to match up with patterns in your mind. That's what happens when we look at Mount Rushmore. If we didn't know about presidents and marble and statues and all of that, we might think that it's just purely naturally formed. So it takes a designer to know a designer. It takes an intelligence to understand that you're dealing with an intelligence. And if you don't have enough intelligence, you may not be able to discover it. That was a problem in Darwin's day. Darwin knew so little biology that he could look at a cell and say, oh, it's just a blob of protoplasm. It's just things floating around. Now we look inside the cell and we see an automated city. We find that we have to be engineers to understand what's inside the cell, and when we look inside the cell, we find a level of engineering that exceeds anything that we have come up with. So why should it be a stretch to think that there's real engineering there? It shouldn't be. Look, I'm not the unreasonable one here. It's there's an old New Yorker cartoon which shows an attorney with his client. And he says, you've got a very good case, Mr. Pitkin. Now, how much justice can you afford? I think we've got the better case. Unfortunately, we don't have the bankroll. We don't have the NSF in our pocket. We don't have the government. We don't have the media. We don't have the education system. When I say the education system, not just the secular one, but also the CCCU, there are very few schools, very few Christian schools where a guy like me or a guy like Steve Meyer could get a job these days. So that's something I hope that sinks in, just what sort of opposition we're dealing with to these ideas. So turn to the point at hand. You get this combination of improbability and specification. It, as it were, triangulates on intelligence. It's something we use over and over again. We use it in the Search for Extraterrestrial Intelligence program. It's a standard sort of statistical methodology that we use to identify intelligence. And when we apply it to biology, what do we find? Well, it seems that we, in fact, find that it does apply to biology and that it reliably confirms intelligence. I'm probably gone a little too long, so let me just say this. I codify this way of identifying design, something I call an explanatory filter. So basically you look, did it have to happen? That's what contingency asks. If no, is it complex? If yes, is it specified? If yes, then it's designed. It seems to be a reliable way in which we identify the effects of intelligence. I wrote this up in a book, Design Inference, published with Cambridge University Press in 1998. When I published that book, actually my job prospects looked very good. Subsequently published and showed how these ideas apply to biology, and then my career went down the toilet. So that's how this game works. So, and you know, I wanted to write a sequel to this book with Cambridge, and my editor there said, don't even bother, essentially. Even if the academic editors this side of the Atlantic accept it, you should expect the biologists on the Cambridge syndicate to shoot it down. And so this is the type of stuff we deal with. So where do I want to leave this? You know, I think, just to recap, there are a lot of good intuitive reasons to think that we are dealing with real intelligence in biological systems. We have to be engineers to understand what's going on there. There are methods of design detection which are now also then reliably pointing us to intelligence with these systems when we apply them. And these methods then have actually led to further work on information theory, and I'll address that in a subsequent talk. What can you do about this? You know, I want a little call to action here, you know, so because it's enough, you know, just to say, I don't think it's enough just to say, hey, you know, here are these great ideas, here's the stuff that's happening. So I think, you know, if these ideas are going to prosper, it's going to need workers, you know. It's not enough to have spectators. It needs, we have to attract talent for this. And unfortunately, it's hard to attract talent for this. Why is that? Well, Steve showed the clip from the movie Expelled. There is very little research funding for this stuff. You know, let me flip it around. When I was a graduate student, my first graduate course of study was actually in psychology. It was experimental psych. That's how I got into statistics, and from there into mathematics. But very hot back then, this was in the early 80s, was cognitive science, which was a merger of philosophy, neuroscience, psychology, various disciplines. Thing is, it was a hot field, lots of money, lots of interest in it. You get a PhD in some field related to cognitive science, you had a career, you had money coming, you had prestige, all of this. What is it with intelligent design? You know, well, it's not like that. If anything, the incentives are on the side of people to bash it. I know some mediocre philosophers who have chairs and tenure and all of that who've made their career out of going after intelligent design. Judge Johnny Jones, the judge who presided over the Dover case, in which he ruled that intelligent design was not just science, but that one shouldn't even question Darwinism. His claim to fame, by the way, before being the judge in that case, was to head the Pennsylvania Liquor Commission, so he was not particularly expert in philosophy of science, understatement. He was voted by Wired magazine, I think one of the 10 sexiest geeks of 2005. Time magazine regarded him as one of the 100 biggest, intellectuals of the year, you know. So the thing is, how you come out on the side of this debate ends up, you know, it can really scorch you or it can help you, you know. And and actually, I think to this day, it's probably more of a career advantage to go against intelligence design. So what am I saying? I'm circling around this. We need help. I think there's, what can you do, you know, in this regard? I think certainly inform yourself. Realize what's at stake in this debate. This goes to the origins question. Everything follows from the origins. You know, you look at our society and all the crazy things that are happening in it. You know, how is this possible? Well, you know, I come at this as a mathematician. Your starting points and how you reason from there, that determines everything. If your origin story is wrong, if humans are not exceptional, if we're not created in the image of God, you know, if we are the result of a blind evolutionary process that did not intend us, well, what does that make us? It makes us a complicated piece of matter. That has a lot of implications for abortion, for all these issues that you think are so important as the Church of God. Church of Jesus Christ. And yet, this is where it starts. So I think you've got to inform yourself, see why this is important. And then I would say, if you've got kids, encourage them to get involved in this debate, either get a degree in this. Ultimately, ideally, go for a PhD in something like molecular biology or information theory or something, or on the cultural aspects of this. But we really do need workers, talent, and a place like Discovery, and they didn't put me up for this, but it's certainly, we need funding because we're not getting it from the NSF. We've got plenty of people that are worthy of research funds, but it's not going to come from the government, at least not at this point. So anyway, leave it there. Thank you for your attention, and I think pass it off to Scott, and then he can tell us what we're going to do.